You know, every single number you see every day is actually part of a secret code, a hidden language that gives it all its power and meaning. And today, we're going to crack that code together. So let's dive right in.
It really all starts with a pretty simple question, right? How can the same digit, like a 5, mean so many different things? The number 5 itself never changes. So what's going on? Well, the answer to that is basically the key to understanding, well, all of math.
So, the secret? It's something called place value. And the best way to think about it is like a digit's home address. You know how an address tells you exactly where a house is? Well, place value tells a digit exactly where it is inside a number. And that location, that one specific spot, is what determines its real value.
All right, let's start by checking out that address. We'll start with the basics, just whole numbers. Think of this as the first clue to cracking the code.
Okay, so take the number 3. See how it's sitting all the way over on the right? We call that the ones place. Its address is super simple, and so is its value. It's just 3. That's it.
But now, watch this. What happens if we move that same digit just one little spot to the left? Now it lands in the tens place. And suddenly, it's not just 3 anymore. Its value just got multiplied by 10. It's now worth 30.
Let's do it one more time. We'll move that 3 one more spot over to the left, and now it's in the hundredths place. Boom! Its value gets multiplied by 10 again. It's now worth 300. That's 100 times what it was worth at the start, just because it moved 2 spots.
So here's the big takeaway. This is the fundamental rule of our entire number system, right? Every single time a digit takes one step to the left, its value gets 10 times bigger. That's it. That's the engine that makes all our numbers work. Now, this brings up a really important point, the difference between face value and place value. Okay, so face value is just what a digit looks like. A 5 is a 5. A 2 is a 2. Simple. But its place value is what it's actually worth because of where it's sitting. So in the number 352, the 5 has a face value of, well, 5. But its place value is 50.
And for really big numbers, the system is actually pretty clever. We use commas to group the digits into these little sets of 3. We call them periods. So you've got the ones period, then the thousands period, the millions period, and so on. It's what makes a huge number like 1,234,567 suddenly not so intimidating to read.
Okay, so we've pretty much cracked the code for whole numbers. But what about the little guys? The numbers that are just parts of a whole? This is where things get really interesting, because now we get to introduce a very powerful new character, the decimal point.
The decimal point. This tiny little dot is like a gatekeeper. It's the dividing line. It stands right between the world of whole numbers on the left and the world of fractions, or parts of a whole, over on the right.
And here's the really cool part, the beautiful symmetry of it. Remember how moving left makes a digit's value 10 times bigger? Well, moving to the right of the decimal makes its value 10 times smaller with every step. It's the exact same rule, just flipped in reverse. And you can see this rule play out perfectly. To the right of the decimal, you get the tenths place, then the hundredths, then the thousandths. Each spot is a tinier and tinier piece of a whole. So when a number like 123.456, that 4 isn't worth 4 whole things. No, it's worth 4 tenths.
Okay, so why does any of this matter? Why learn the code? Because once you really get it, you basically unlock math superpowers. Seriously, it makes solving all sorts of problems way, way easier.
I mean, with place value, you can line up massive numbers for addition and subtraction and get it right every time. You can multiply or divide by 10 just by shifting a digit left or right. And you can tell in a split second which of two numbers is bigger, no matter how complicated they look.
Let's see it in action. Say we want to compare 567 and 582. You just start all the way on the left. The hundredths place? Okay, they're both 5s. It's a tie. So we move one spot to the right, to the tens place. And there it is. We've got a 6 versus an 8. Since 6 is smaller than 8, we know right away that 567 is the smaller number. The very first place you find a difference, that's what decides the winner.
And you know what? The exact same logic works for decimals. The only trick, the one thing you have to remember, is to line up the decimal points first. So if we're comparing 0.65 and 0.628, we see the tenths place is a tie. Both are 6s. Then we move to the hundredths place, a 5 versus a 2. And 5 is bigger.
So 0.65 is the larger number. It totally doesn't matter that the other number has an extra digit at the end.
Here's another cool way to see the power of place value in action. We can actually break a number apart. It's called expanded form. It's kind of like lifting the hood of a car to see all the individual parts that make it run. So a number like 123.45, what is it really?
It's this. It's really just 100 plus 20 plus 3 plus 4/10 plus 5/100ths. Each one of those pieces is the true value of that digit because of its specific place. When you see a number broken down like this, it's like you're seeing its entire DNA laid out right in front of you.
Okay, but this isn't just some abstract math thing, right? This secret code is literally running the world around us. We use it all day, every day, probably without even thinking about it.
Just think about money. $12.50, that is pure place value in action. Or measuring something, say 1.5 meters. That's 1 whole meter plus 5/10 of the next one. Seriously, every time you read about a city's population, check a sports score, or even use your computer, you're seeing place value at work. It's like the invisible architecture of our whole numerical world.
So you see, place value isn't just another math lesson. It's the key. It's what unlocks the entire kingdom of numbers. It gives you the power to understand them, to compare them, and to use them with confidence. So the code is cracked. Now the only question left is, what are you going to build with it?